Now look at this guy. This is 2/5 the absolute value of x. You know the shape already, right? What's the shape going to be? It's that V shape that we expect. It's 2/5 though. Look at the notes that we just took. Is this positive or negative?
That is positive.
It's positive, so we know we're going to be opening up. Is the 2/5, now you have to compare it to 1. Because this guy right here, you know the V shape, right? Is that 2/5 larger or smaller than 1?
Less than.
It's less than 1, so what do we say about that?
That's up and down.
Now hold on, don't. When we talk about stretching and compressing, it's not this way. It's in a vertical way. So here's this shape. Am I going to stretch it or am I going to compress it? Since it's less than 1, that's a compression. Now what that means is that whatever your normal shape is, if it was like this, I'm going to squeeze it down to be 2/5 that height. Okay? So
Why is there an X there? Why is there not a number there? Should there be a number there?
here, your x is a variable because x can be anything. So when you do your graph, x runs through the whole domain. And as you saw with the original shape of your absolute value, the domain is all real numbers.
Okay.
Okay? So my vertex, did I go up, down, left, or right at all? Is there any adjustment on the inside of this? Is there anything added or subtracted outside of this?
No.
So your vertex is still where?
Zero.
Bless you, at the origin. Your 2/5, let me show you how this guy works. Since this is an absolute value, and this only works for absolute value, guys. We talked about how the absolute value is made up of these straight pieces, right? And if it's made up of these straight pieces, then I can use this 2/5 as a slope. So from this point, what will I do?
Go up to,
Go up to
and then over 5.
and over 5. I could keep doing this, but I kind of run out of room. I could reflect this back over here up to the left 5. Bless you. There's a, so every day you keep adding a sneeze. I feel like I need a sneeze. You can find the midpoints here. Instead of going 5 and 2, you can go 2.5 and 1. I think the more points you have, the more accurate your graph is going to be. Okay. Now I want you to see your original absolute value. Can you see that this guy has been squished down a little bit, right? You took the original shape and you squished it down. So I connect the dots, the points.
It's hard to think of it like that.
It's hard to what?
It's hard to think of it as a compression. instead of
How do you want to think about it?
Yeah, that's what we got.
It's like, cause like usually
Oh, it's
you would say,
called-
oh, wider or narrow.
Okay, yeah. So
Yeah, that was taught that. It doesn't really wide.
so you were talking about you were taught wider or more narrow.
Like it's confusing when you say compression. It's confusing. I still think it's compression.
Well, f of x is your y, right?
Mm-hmm.
What do you know about your y's? Well, I want your y's to be 2/5 what they were originally. So your y was your height, right? I want you to be 2/5 of that. So I'm gonna squish you down. Okay. I'm gonna crush you down because it's compression. You see, if I were to say put a 2 in front of this, it made it steeper, right? But I'm doing a 2/5, so there's my graph. Okay. Now this is really nice to work with when you have absolute values because this guy right here is like pretty much straight up a slope. Okay. That means if I were to do
Oh, yeah. MX. Y equals MX. That's what that is. If X is Y. It's right there.
if I have this, -3 times the absolute value of x. The absolute value tells you your shape is going to be what? A V. What does the 3 tell you?
It's going to be above 1. So
It's going to be
steep.
3 times the height, basically. So that means you're stretching that out to accomplish that, right? So you're going to stretch it out, so your shape is going to be stretched out, okay? And what about this minus here in front?
It's gonna be going down.
It's going to be flipped upside down. Okay, so let's put all of that into our picture. So we've got a V shape. The 3 tells me that we have a stretch, but the negative tells me I'm going to be upside down. Where's your vertex though? You gotta know where you start. Where's your vertex?
It's still a 0.
It's still at the origin at 0, 0, but now I'm going down, so I know it's going to be opening down like this. How do you get your other points though?
I want you to just multiply it times, I give you.
1 times 3.
-1, -3.
Right, I give you 1, absolute value of 1 is 1 times negative 3 is negative 3, but since you've got absolute value, I'm just going to use the slope. Down 3 over 1. Down 3 over 1, and so on. Do the same thing over here.
You're saying that only works when you have the absolute value though?
You can only do slope with the absolute value, and the reason for that is because absolute value has straight pieces. That's why we can do that. We're going to look at some parabolas here in just a moment. You're going to see there's a little bit more work that goes into that. I feel like I should use a ruler. Oops. Move this up a little bit. I'm not a perfectionist. I just need things to be done a certain way. You know, mistake free. It's just. Okay. So let's see. There's absolute value of x. There's 3 times the absolute value of x. And then finally, the negative turned it upside down. Any questions about that?
Non-linear.